Hey, what's happening, guys? Welcome to an exciting new series, a tutorial series I'm starting that is going to be a blueprint ability system. And if you've been following my other tutorial series, my interaction and inventory system tutorial series, we're getting to the point to where we need to start equipping items. And I was thinking about doing a really simple implementation, just like for this input, check a boolean or two, and then run the equip action if you're able to. I was thinking of doing some simple implementation like that for our abilities and actions associated with our equipment, but I've decided to make or create our own ability system that is based off Epic Games gameplay ability system, but it is 100% in blueprints. And I think that's the best way to go. So I'm going to branch off of that interaction and inventory system. If you haven't followed that series, you'll be able to follow this one just fine. But if you are following that series, then this is going to be the logical next step to where we do the implementation for running any amount or any type of action. And then in the next episode of that series, we're going to migrate this system over and start creating our equipment and being able to equip it and stuff like that. Before we jump in, I just wanted to explain what is the purpose of an ability system. So basically, if I pull up this is just a blank third person template. I'm starting completely fresh. If we go to our third person character, now if you were going to not if you were going to perform actions based on inputs without an ability system, it would look something like this. And if we wanted to, for instance, let's say we wanted to sprint or whatever, so we would probably create a boolean. Say we wanted to sprint and we wanted to jump. We have this jump right here and we have this sprint. So, and then let's say we have, a shoot or something. So basically, if we wanted to shoot, we would probably create a boolean that we enable and disable based on if we're sprinting, if we're jumping, if we're shooting. And if we want to shoot, we'd have to check if we're sprinting, check if we're jumping, right? And only if we're not doing both of those, we can actually shoot. And then for sprinting, we probably, if we're sprinting, we want to stop the sprint. If we say we're sprinting and we want to jump, well, we don't want to not enable us to jump in that case. We just want to stop sprinting and then jump. And so just with these three examples of a jump, a sprint, and a shoot, you can see how it's getting very confusing. And you could see how if you had 20, 30 abilities or actions, you would it'd get really, really confusing and really monolithic, like extremely quick, to where you're doing a bunch of one-off checks and booleans, and it gets really messy. The beauty of an ability system or an action system, which an ability system is more or less just an action system, is you can create a framework to define when and where you can do certain abilities and just define them in a data table or something like that, and basically set it all up. And so if in our ability system, for instance, if we wanted to sprint, we would get our sprint key, and we would just say, try to sprint. And our system will work out if we can sprint, if we can't sprint, etc. And when we go to shoot, our system will automatically work out, hey, we need to stop sprinting. Hey, we need to stop jumping. Hey, we need to, and all these things. And it's just based on the data that we input. We're going to input into our data table, and we'll have a bunch of data. And then in our components that we'll create, we'll work out the functionality to basically go through all the conditions and everything we need to on whether or not we can implement each individual ability. And the key to this is going to be our ability behavior objects, so an ability is going to be defined as just a bunch of data, an ability gameplay tag, maybe a cooldown, optional, if it's optional or not, stuff like that. And yeah, and so basically we're going to use objects to encapsulate any behavior that we want to run for abilities. And this can get actually really hard to keep track of if we needed an ability object for each ability. For instance, if we had melee, sword, light attack. If we needed to create an object in our content browser for melee sword, light attack 1, melee sword, light attack 2, melee sword, light attack 3, you could see how we're going to have 50, 100 of those ability objects, and it can get really hard to keep track of. But the way we're going to do it is we're going to have ability objects that are basically like play montage. And then in our data table, we're going to be able to define what montage we want for different abilities and stuff like that. And that makes it to where by the end, you may only have 5, 10 ability behaviors, but the data is interchangeable, because we don't really need, if we want to play a montage for jumping and sprinting, that functionality is largely the same. We don't need to create play montage jump, play montage sprint. We can just have a play montage ability and pull whatever montage we define in the data table in when we run it. So this system is slightly advanced, and it may be confusing because we have to create a lot of data first. But I will try to explain it the best I can, and we'll go from there. So the first thing we're going to tackle is the data portion of it. So in our content browser, I'm going to create a folder, and I've been calling it when I've been testing it out in a project, I've just been calling it BPAS, so Blueprint Ability System, which is, BPAS. I'm just calling it BPAS, and it's largely based off of the Gameplay Ability System by Epic Games, but you cannot really set that up without going into C++. So we're not going to make the system as like their implementation is very modular and it is very scalable, but it is also a little bit cumbersome to maybe more beginner and intermediate users. So we're going to scale it down, make it a little bit more simpler, but still pretty advanced, and we'll see what we come up with. So this episode probably is going to be a doozy, but let's strap in and get going. So the first thing we're going to do is create our master folder in our content browser. I'm going to call it BPAS ability. Well, I guess I can just call it BPAS system. There we go. Well, no, blueprint ability system. There we go. BPAS. I'm going to color it just to make it stand out to my eye. I'm going to go in there and I'm going to create a folder called ability behavior objects. Now, the beauty of a system like this is if you set it up right, you can use this for anything. So if you have AI that needs to perform actions, if you have wildlife that needs to perform actions, enemies, whatever, you may have to tweak it some for each individual thing, but the goal of a system like this is to where anything in the game, any entity in your game can use this exact system. So our ability behavior objects, we're going to go into Blueprint class, and we're going to go into all classes, and we're going to create an object. I'm going to call it ability behavior base. Now, I do like to split these from into player ability behaviors and AI ability behaviors. So I'm going to say ability behavior underscore player, and I'm going to duplicate that and change player to AI. And I'm just going to throw those in a folder real quick. AI behaviors, player behavior. Well, let's say objects. AI behavior objects and player behavior objects. I'm going to throw the AI behavior in there and the player in there, and cool. So we got that. So let's go into our ability behavior player. Let's create a child of this and just call it ability behavior player, and we'll say play montage. And that'll pretty much be the only one we'll use today. Our goal for this episode is just to get everything set up to where we can at least debug it and start going from there. So let's go into our BPAS folder, and we're going to create another folder called components. And we're going to split, instead of making one component, one BPAS component, for instance, and just having a lot of stuff in there, we're going to create 3 components. One is going to be our BPAS ability manager component, and associated with this is going to be a BPAS attribute manager component. And I'm going to duplicate that. And another one associated with this is going to be a BPAS gameplay tag manager component. And the way we're going to set this up basically is if we give any entity in our game an ability manager component, they're going to have an attribute and gameplay manager component as well, because this ability manager component will need these things to correctly activate, deactivate, and manage abilities. However, you'll still be able to give this attribute and gameplay tag manager individually or separately to other items. So for instance, in our equipment, we might want to keep track of durability. In that case, we would just throw an attribute manager on that equipment, and we wouldn't need these other two components. So setting it up this way, I think, is the best case scenario, because otherwise you'd have to create a whole nother attribute system when we can make use of these. Even though some items you may want attributes on some entities, and you may want to manage gameplay tags on some entities, but you won't want abilities or actions associated with it. But if we want abilities and actions associated with something, we're going to set it up to where they have to have these two components, basically. So we can go into our BPass folder again, and we're going to create another folder called data. And we're going to jump in here and start creating all the data we need for this system. So we're going to create a struct s underscore, I'm going to call it ability base data. And we can go into here. And basically we're going to be using gameplay tags to run our abilities. Now, our behavior ability objects will not have a gameplay tag associated with that specific behavior object, but we will pass in a gameplay tag so the behavior object that's running knows what ability it's associated with, because an ability in this scenario is just an abstraction. An ability, quote unquote, is nothing but data. We don't have like an object that's an ability or an actor that's an ability. It's just an abstraction of a bunch of data. So when we activate an ability, we're gonna create an ability behavior object, and we're gonna pass in our ability tag. And that way, when we go to cancel or end that ability behavior, we can just call, hey, cancel this ability, and then that ability object knows to end because it knows what gameplay tag it's associated with, if that makes sense. So if my mouse will come back, seems okay, there we go. So I'm going to say ability tag, and that's going to be of type gameplay tag. Okay, now we're going to need a lot of gameplay tag container variables, and they're going to be just to check things like, can I activate this ability? Is it blocked? Do I need to cancel these other abilities? Do I have the certain amount of attributes required to run this ability? What happens when this ability is activated? That is all the stuff we're going to define in here, and we're going to make use of gameplay tags as much as possible. So if we go in here, we can add variable. We'll say activation grants tags, and we need to change this to a gameplay tag container. And we'll have another variable of the same type, and we'll say activation removes tags. So basically, we're going to use gameplay tags to manage the state of items and entities. And so when we activate a certain ability, we may want to add gameplay tags to that entity. For instance, if we have a sword and we press the attack button, we're going to add, hey, we're attacking. We're going to add the attacking gameplay tag to the person that's attacking. And that way, if the world or any other entity needs to check something, it's an easy way to know that, hey, they're attacking. And we can actually set it up to where certain entities or game items that want to subscribe and be notified to when certain things happen, you can use the same exact system. For instance, all it would take is for our AI enemy, if we had an enemy AI system, it'd be really easy for it to say, hey, I want to know when the player is attacking. All it would have to do was get a reference to the player and subscribe to be notified when the attacking tag is added to the player's gameplay tag manager, if that makes any sense at all. So these are kind of self-explanatory. These will be the tags that when we activate an ability, these tags are granted. When we activate an ability, these tags are removed. There may be some scenarios where you want some tags removed when they activate an ability. The next one we're going to say is deactivation grants tags. and deactivation removes tags. And this is deactivation. Yeah. And that's the same thing. So when we deactivate an ability, so basically every ability is probably going to have, when you activate an ability, give it this tag, these tags. And when you deactivate it, remove these tags, which is going to be the tags that you granted. But they may be different in some scenarios. I don't think I have never come across an instance where I wanted to remove tags on activation or grant tags on deactivation. The only thing I can think of is basically if you're setting up a Souls-like game, for instance, you could do some stuff with invincibility and things like that, but these are just there. These are all there just to cover basically any instance you might run into. So we'll create another one of gameplay tag container, and we'll say source restricted tags and source required tags. And we'll make another one called target restricted tags and target required tags. Now, basically we're going to pass in a target for abilities. Now, this probably won't be used much for the player character, but for instance, if you're enemy AI, they're going to know what target they're attacking. And so we can pass that information into the ability system. And let's say you have an enemy dodge. Let's say you have an enemy AI ability that is for them to dodge. Well, you can set it up to where, hey, I know the enemy AI is going to know their target is the player. And when we go to run this dodge ability, it's going to check and it's going to say the target required tags. So it's going to, the ability system in our data table, you're going to create the ability for, enemy AI dodge. And when that ability, and in the target required tag section, you're going to put, hey, so for this enemy AI to perform this dodge ability, the player needs to be attacking. And so you're going to put, target required tags, attacking. And before the dodge ability is executed, the ability system component, the ability manager component, is going to check, hey, does the target, which is the player character, does it have this attacking tag? And if it doesn't, it won't run the dodge. So these kind of things are very, like I said, the target restricted and target required, you may not use as the player. You definitely can, but you'll definitely use them for enemy AI and other entities that are using the system. And let's create another variable. So we're definitely going to need more. Let's create another one of type Boolean. And we'll call it optional ? And then a float for percent chance to execute. And again, these optional and percent chance to execute, you can definitely use for the player, but you may not. You probably won't use it that much, but you will probably use it a lot for enemy AI or other entities. And same thing, cooldown. We'll put cooldown. And again, you may not use it for the player character, but you'll definitely use it for enemies. And we'll make another Boolean for Q if blocked. And this is a cool one because say that we have a sprint ability, and while we're jumping, we press the sprint button, but we're jumping, so the sprint ability gets blocked. Well, if we check Q if blocked, then we can tell that sprint ability, this sprint ability is blocked because we're jumping. But if we check Q if blocked, when that jump ability ends, we can say, hey, is anybody waiting for this? Is any ability queued and waiting for this ability to end? And the sprint ability can look and say, oh wait, the jump ability blocked me. The jump ability just ended. Let me try to activate. Cool. And we need one more gameplay tag container for combo abilities. And we'll say gameplay tag container. And basically, I like to have this this combo abilities gameplay tag container variable because say we have an attack combo, and in our data table for abilities we have attack 1, attack 2. Well, in our ability behavior object, we're going to have an event on what happens when multiple calls to the same ability occur. And in that instance, we can check, and if a combo ability exists, then bam, we can, we can start going into trying to execute those abilities instead of just nothing happening. And actually, it'd be best, so we can put these in order, it'd be best to just make an array of gameplay tags. Because if we had a gameplay tag container, we'd be able to select a bunch of gameplay tags, but we wouldn't be able to put them in a specific order. With an array of gameplay tags, we will be able to put them in a specific order. So say this is my jump ability. So if I want, when I hit the jump ability, when I hit the jump key, when I'm already jumping, the first thing I want to do is attack. And then the second thing I want to do if I hit it again is attack again, or attack two. So that'll be a little better. Now we need one other variable, which is going to be our attribute cost, if there is one associated with it. So let's create a structure that is for our attribute data, first of all. And first thing we're going to do is create basically the values that an attribute will need, which is going to be min value, and that'll be a float. Max, or let's say current value, max value, and we can actually have a base value as well. We'll have a Boolean for auto regen ? And then we'll have another float variable for regen delay. We'll have a regen rate float and a regen amount. And basically this auto regen, regen delay, regen rate, regen amount is just for something like sprint. Think about for a sprinting attribute or a stamina attribute. Basically just filling out this attribute information. When you're sprinting and you stop, we can say, hey, yes, we want to auto regenerate. We want to wait 3 seconds before we start regenerating. And the rate at which we regenerate and the amount. So we want, 20 amount every 1 second until max. And I found it doing it this way. I used to only have these first four, but handling the auto regeneration within our attribute data, I think can go a long way. Now we don't have an attribute tag here because we're going to create a map in our attribute manager, and that's going to have the tag associated with this. We do need an enumeration. So let's create a folder for our structs and drag them in there. And let's create a folder for our enumerations, enums, and let's create an enumeration for our initialization method. So let's say attribute initialize, e_attribute initialization method. And basically we want to define how to initialize our attributes, and I'm going to define that as basically what do we set our current value to on spawn. Because for some instances, like hunger, for instance, you may want to spawn with 0, but health, you might want to spawn full. You might want to spawn at your max. You might want to spawn at your min. So we'll say, so this is our attribute initialization method. We'll say current to min, current to max, and current to base. And that will give us the option. So this is our attribute data. We'll put this new variable first, and it'll be of type attribute initialization method. And we'll say attribute initialization method. And that way we just have to basically define the min, max, and base. And we can say, okay, when we spawn, where is our current? Where is our current going to go? So, and we'll need, in our structs, let's create another, we'll need a couple enums. So let's create a couple more enumerations, which are all going to have to do with editing attributes when we want to edit attributes. So we'll say e_attribute attribute edit operation. And this is going to be like, what math operation would you like to perform on this attribute? We'll say add, subtract, and I don't really know of a system that you would want to multiply or divide, but excuse me, we may well put those just in case you run into that and you need to multiply or divide them. We'll say e underscore attribute edit method. And this is going to define how do you want to edit this attribute. So say an attribute costs 20 mana, or say, like sprint, for instance, that drains over time. So that'll be for a duration. Or, well, let me define the options first. So we have instant, we have permanent, temporary, and for duration. And so basically these are all the methods, these are all how we will handle editing attributes. So for instance, instant, if we select instant, then whatever the attribute costs for an ability, we're just going to take it, subtract it instantly in one frame. Okay. Now a permanent change will I usually put this to affect the base, like the base instead of the current. That'll forever change the base of the attribute, which means you can't regenerate it. Because the way it works is you're going to you can go between min and max with your current. But we're going to set it up to where if you change the base, or maybe you can define the current based on the base, but the permanent basically, so instant means you have 100 mana, this ability costs 20, you take away 20. Now your current is 80, but your max and base are 100. Permanent would be it takes the max and base down to 80, so you cannot regenerate it anymore. It's like a permanent cost. Temporary would be like, okay, so we're going to take 20 when the ability is activated, and we're going to give it back when the ability is deactivated. And for duration would be like a stamina when you're sprinting. It'll only for the duration you put in here, that is how much we'll edit the attribute. And we're going to set it up to where if we put 0 in the duration, then it's going to go until the ability is deactivated. So we have those two enums. Now we can go into structs and create our blueprint struct for s underscore attribute edit data. And then we can say, so attribute, we want to know when we edit an attribute, we want to know what's the tag we're trying to edit. So what's the gameplay tag for this attribute? We're going to say edit operation or edit method. Say e underscore attribute edit method. We're going to say edit operation. That'll be our e underscore operation. I'm going to say amount. This is going to be the amount to edit it by. This is going to be the duration to edit it by. And this is going to be the rate to edit it by. So for instance, we have an attribute tag for health. We're going to say, okay, I want to edit this attribute for this duration. I want to subtract 25 every second for 5 seconds. And basically we can do all that from right here. We can actually, let's create another. I was going to just add the context of the editing, of the attribute editing to this structure right here, but let's create another one for that. Say s underscore attribute edit context. And this is basically going to be instigator. And caller. So this will be if you need to know who is editing this attribute, because when we edit the attribute, we're gonna put in whatever actor it belongs to. Now the caller is gonna be what. So for instance, if you have a player, if you have a character and it has a weapon, and you're trying to edit the enemy's attribute, when we call edit attribute, we're gonna put in the enemy for the owner of the attribute manager. The caller is going to be the weapon, because the weapon is the one that is actually causing the damage, but the instigator is really the player, which is like the one, that instigated the change. And in my context, I usually, just in case you need to pass in other things, I usually like to have at least one optional object. Just in case there's, in your damage system, you may have a damage calculation class or something like that you need to put in here. So I like to at least just have that. But now we can go back into our ability based data, and we can create a variable for commit cost. We can make this single, I think, or let's see, attributes s underscore attribute data. And this will tell us how to handle the editing of, and we actually do need this to be an array because, for instance, it may cost health and stamina. So, oh wait, that was our attribute data, not our attribute edit data. There we go. And so our commit cost will define how we want to handle editing the cost of this ability, if it even has one. So let's see. And let's create one more struct for damage data. And that's going to be just in case you want to associate damage with this ability. So we're going to say damage type, float, damage amount, oops, not a question mark. And this is just an example. We won't even use this in this video, but I'm just setting this up as an example. Let's say, there we go. And we want gameplay tag for damage type. And then we have these right here. And actually, let's create our visual data. And this will be our, for instance, what montage to play. Say play rate, where if we want to edit the play rate. And we can even get to where we can assign what particle systems to use and stuff like that from here. So let's just go VFX and sound effects. There we go. We can go back to our ability-based data. We'll add our damage data. And we'll add our visual data. Cool. And I'm going to put this combos at the end, and I'm going to put the optional % chance to execute and cooldown at the end as well. And let's just save all real quick. And I think we're safe to create our data table. So I'm going to create a folder called tables, go to data table, and we'll create a data table based on our ability based data. I'll create a data table called ability definitions. And there we go. And if we create a row, here is all our ability data. So let's go into our BPass. Let's create a folder called blueprints. Create a folder called game. And let's create a blueprint function library to where we can house some BPass, BPFL. Let's create a function library so we can house any frequently used functions. We can put them in here. So let's say get ability definition by tag. We can make an input for gameplay tag. Oops. We'll say ability tag. And we will get data table row names, make it our ability definitions data table. We'll pull off of here and do a for each loop with break. We will then get data table row, hook it up to here, create an ability definition, and we will break out of the out row, and we will just check if our ability tag matches. If we type get ability tag, we can get this variable right here without having to pull it. We'll just type it and get it right here, and we'll just see if these two match. And if they do, then we will come right here, promote to local variable. We'll say found ability definition question mark and make this local. We'll unconnect this and just put a check right there. And then we will get this out row and say ability definition found local. And we will connect it up right here. And then we will take the output of that node and go all the way to break and just drag those above right here, reroute them, make it look a little pretty. And for our return node, we will just take these local variables and connect them. And I'm just gonna get rid of this local stuff at the end. And we can actually mark this pure as well and connect this to completed. And I actually just realized that we don't have the most important thing in our ability-based data. We don't have our ability object. So we'll say ability behavior object, and we'll make this of class ability behavior base. And we'll make this a class reference actually. And we'll come up here and put it second. I like to put it second usually. And there we go. And now we can choose what behavior we actually want to add. And we have this right here. We'll say get ability definition by tag. Okay, cool. And this is where we're going to create stuff like, let's see, check our bpass check has tags, and we'll do, bpass edit attribute, that kind of stuff. So this will be full by the end. And let's actually lately I've been liking to prefix all my functions in my function library just so I don't have to, look through all the stuff in these menus. I can just type bpass and they're right there. Cool. All right. And so before we dive into the ability manager component, let's actually go into our ability behavior base, and we're going to create a few functions and events. So let's create a variable of type character, and we'll say owning character, and we'll make this instance editable and expose on spawn. We'll duplicate that and say owning bpass manager component and make it the bpass ability manager component object reference. And if you duplicated this one for this one like I did, then instance editable and expose on spawn should be checked. And we will create another variable for ability based data. Now we may want to actually only pass in the necessary, because some stuff won't be necessary to the objects. Like we really only need a couple things, but for now I'm just going to pass in all of the ability data. And if we run into any problems with speed or anything like that, then we can optimize it further. So we'll say ability based data, or we'll say associated ability based data, and make it instance editable and expose on spawn. Let's go into our data folder and our structs folder. We do not have an ability event context. So let's go blueprint structure. We'll say ability event context. And same thing, we're going to say actor, caller, instigator, and this is where we're going to put our target if there's a target. And then we can say optional object number 1. And that's just in case down the road you may need to pass in something. There we go. We can go back into our ability behavior base and create our ability event context. Say associated ability event context. Make that instance editable and expose on spawn. And we'll create one more variable called show debug ? And make that instance editable and expose on spawn. And I'll actually put all these in a category called passed in. There we go. And we'll create the few functions that we're going to need to override in our child classes. And if you're not familiar with objects, so actors, if you're familiar with Unreal Engine at all, you should be familiar with actors. Now, the difference between objects and actors is an actor is something that you can drag in the world. An object is not. It never is in the world. It doesn't have any kind of world context. And another great thing about objects is they're lightweight, but also as soon as there's not a reference somewhere to an object, it is destroyed. So for just running some kind of functionality that is just kind of a one-off thing that is not necessarily related to anything in the context of the world, objects are great. They're really good and they're perfect for stuff like this. So let's create a couple functions, and we're going to say activate ability, deactivate ability, cancel ability, and I'm going to create another one called additional ability calls. Or let's say on additional ability call. On additional ability call. Cool. And these are just the functions that we're going to basically override in the children. But what we will do here is do a print string, and you see this world context object. Anything that needs a world context object does not have any kind of context to the world or the scene. And so activate ability, and here we're just going to show debug, and if it's true, we can actually drag off this in string and we're going to append it. Now we're going to get the ability base data, split it, and we just want the tag right here, get tag name. And I'm going to put a couple spaces in this B input, and in the C input, I'm just going to put this tag name. And right here, I'm going to put ability activated, : and so when this triggers, it will ability activated, and it'll say the name of the ability that's activated. And I'm actually going to copy this because I'm going to do the same exact thing for all of these. And when we override this function in the children of this object, we'll be able to make a call to the parent function to be able to call this debug message or these debug messages, and then implement whatever functionality we need. So we'll say ability deactivated : we'll say ability canceled : and we'll say additional ability call : cool. There we go. And I think we can close that for now. I'm just gonna, if you right click on a tab, you can close tabs to the right. So I'm just gonna get rid of everything, and let's go into our project settings and create a few gameplay tags. If we hit the plus button right here, we can get our default gameplay tags INI, and we can say bpass for our blueprint ability system, and say ability, and we can say just say general, and I'm just creating a subcategory for general. You can create one for movement, for combat, whatever. I'm just going to say bpass ability general jump and general sprint. And for instance, the way we're going to do it is we can say ability event, say check for check combo continue, event reset combo data. Cool. And while we're in here in our BPass system, we can create some attributes. So attribute health, attribute stamina, for instance. And then we'll actually create some tags that are outside of our blueprint ability system as well. We'll say state, character, main, unarmed, for instance. We can do stuff like that. And then I usually like to have a character. When I do states, I usually like to have a main state for unarmed and armed, and then a secondary state for things like jumping and sprinting. So I'm going to say state, character, jumping, sprinting. Cool. And now that we just did the event tags for our ability system, I'm realizing we forgot to, in our ability based data, we forgot to add a variable of gameplay tag container. Oops. For relevant ability events. And I'm going to move this up to right after target required tags. We'll say relevant ability event tags, actually. Yeah, and that's just basically going to be, we'll be able to send events to our any gameplay ability. We'll be able to send events to any blueprint ability system component. And basically, instead of just broadcasting that event to all the behaviors that are running, we're only going to do that to the ones that have the event tag that we're calling. We're only going to notify the ability of that event if it has the necessary ability tag in the relevant ability tags. That way we're not just sending useless information. Cool. So with that said, I think that let's go into our BPass gameplay tag manager component. And let's create a variable of gameplay tag container. And this will be our BPass gameplay tags. We'll create one more of type gameplay tag. And then we will, over here, we can change it to a map. And that's exactly what we want, an integer. And we'll say BPass tag stacks. And we'll make both of these. No, actually just the BPass gameplay tags. We'll make it expose on spawn and instance editable. Cool. And in let's go to our BPass attribute manager, create a variable for BPass attributes. And that'll be of type gameplay tag. And same thing, we want a map, and the map is going to be to our attribute data. And we'll make this instance editable and expose on spawn. Cool. And now we can go into our BPass ability manager component. And let's create a couple variables here. We'll say default attributes. Oops. We'll say default attribute data. Oops. And that'll be of type gameplay tag. Make that a map. And same thing, our attribute data. Cool. We'll make this instance editable. And we'll say default gameplay tags. And this will just be we need to change this back to single first. And this will just be a gameplay tag container. And we'll make this instance editable. And this, so let me pull up our player blueprint. So basically we can add any component we want, right? We can add all these three components to any entity that is using the BPass system. However, we'd really like to just be able to add this one component to anything that's adding it and set the default of the attribute and gameplay tags from here. And because we're trying to kind of manage the attribute and gameplay tag system through the ability manager component, we're actually going to just add those two components from here. So let's create a function for initialize BPass, and we'll get a sequence going. And the first thing we want to do is get our owner. We will drag off of that and add component by class. And we want to add our attribute manager component. And this is our bpass attributes variable right here that we set to expose on spawn. So when we spawn this component dynamically, this is the bpass attributes. And so if we drag in our default attribute data, that means that this variable right here will be set to that. And so we can pull off the return value and promote it to a variable and say bpass attribute manager component. And as a safety check, we're gonna just make some space and pull off of this variable that we just saved right here. This is it. I'm gonna right click it, convert to validated get. And this will only add the attribute manager component if it is not valid already. And that way, that'll save us from doing any duplicates on accident. So here we go. We'll get this again for get owner and we'll say gameplay, bpass gameplay tag manager. This is our, where is it? Default gameplay tags. Drag it in there. Cool. And we'll do the same thing. We'll promote this to a variable, bpass gameplay tag manager component. And we will do the same thing. We'll drag that in and only continue if it is not valid. And that way we can not on accident have a billion copies of these things. Cool. All right. And let's go into our gameplay tag manager component and create a function for initialize bpass gameplay tags. And let's create another variable actually for, let's make it a single variable and call it show debug. Make it a Boolean. And basically in our initialize bpass gameplay tags, we're not going to do anything just yet, but we will print gameplay tags. We'll make another function for print gameplay tags. And just if we are showing, if our show debug is checked true, which we're going to expose it on spawn, we want to get our gameplay tag container. We want to break it. We want to do a for each loop. We want to get our tag name. And we're just going to print string. There we go. And for now, we're going to just call print gameplay tags on initialize gameplay tags. So in our ability manager component, after we spawn the gameplay tag manager, we can just call initialize gameplay tags. And in our attribute manager, we can do the same thing. What did I call that? No, gameplay tags. Let's say, well, let's change this to bpass gameplay tag manager. And this way, anything we want to do to initialize these, we can. Let's say print, create another variable again. We'll make it a single variable of type show debug. Of type Boolean for a show debug. Make it instance editable and expose on spawn. And we will drag this out, get our keys, and we'll loop over our keys. And we will drag off of that map and type find. And we'll find this key. And if we have found this key, we will get this value. And we will print string. We can append this input, and we want get tag name. We can get this tag name, type a couple spaces, and then put in the current value. Cool. And in our initialize bpass attribute manager, we can just print the attributes. And in our ability manager component, we can just, off the attribute manager variable, we can say initialize. There we go. And this won't do any good right now, really, but we will be doing a couple things probably to initialize the attributes and most likely the gameplay tag manager as well. So I want to create another default variable that is default granted tags, because we're gonna grant default granted abilities. Oh, actually, we may want to do classes and stuff later. So let's say default granted ability tags and make that instance editable. And then we will say granted ability tags. Cool. So we will have, and we'll not make that one instance editable. So these three should be defaults. And basically, this is going to be to where anytime we add this ability manager component to any entity in our game, we can come right here and change these. And let's actually go into our ability manager component, and we're going to throw all the ones that have instance editable, all the ones that are instance editable, we're going to put them in a category called defaults. And we're going to put these that are not instance editable in a category called private and check private. So check private and put it in a category called private. And this granted ability tags, private and private. And that way, when we add this component to a item, we're just going to have this right here. These are the variables that we'll need. And since we actually put all those into a private category, we can actually just leave them in the default category, these three. So when we want an entity in our game to be a part of the ability system, we just add this component. It's going to add all the other components automatically, and we're only going to have these three variables on the side, and we need to know, okay, this entity needs the default attributes, default granted abilities, and the default gameplay tags. And also, let's create one more for show debug ? Of type boolean, and make that expose on spawn as well. And I'm going to keep all the defaults together, so we have that. And then if we go into right here, we have this show debug. Let's connect this, and that way we don't have to click show debug on all these. Automatically be passed in from the parent. Cool. And so now we go into any time we add the ability manager component, it's going to easily just add all these together to add all the components and handle the show debugged if we want. And so basically now we just need to default granted ability tags. We need to break this. And actually we should be able to just append this. So let's say granted ability tags, we can say append. And I don't remember which one of these is which. So let's see. We have append gameplay tag containers, append all tags in the in container to in and out containers. So we want to append the in and out to in. Appends all tags in the in container to the in and out. So no, it's opposite. We want the granted ability tags in the in and out and the default granted there. So on begin play, basically, because we're going to call this initialize on begin play, say initialize bpass. There we go. And so on begin play, all our default granted ability tags, which will be stuff like jump, sprint, maybe whatever, they'll be added to our list of granted abilities. And so if we want to dynamically add granted ability tags, we're definitely going to do that. We can actually create those functions now. So grant ability by tag, and we'll create an input for gameplay tag, and we'll say ability tag. There we go. Just ability tag should be fine. We'll duplicate that. We'll say revoke ability by tag. And let's create another one called try activate ability by tag. And that will take in an ability tag and in ability event context. Cool. There we go. And we'll need some helper functions. So we'll say check source. We'll say check source bpass tags. And basically this is going to check the required and restricted gameplay tags. So let's go into our gameplay tag manager and just create a function for oh, actually let's go into our blueprint function library and do that. So in our bpass folder in blueprints game and our blueprints function library, bpass check has tags. And we'll need an input for so the bpass character or actor actually. And we will get component by class, get our ability manager component. And actually let's create 2 helper functions in here for check has bpass system. We'll say actor to check. We'll get component by class. We'll get the ability manager component. We'll drag off is valid, and we'll get a return node and drag it in the return node. The is valid in the return node. We'll make it pure and change the output to has bpass system. And we'll make another one for get actor bpass system, and we'll make an input for actor. And we will first check if the actor has the system. And if it does, we will get component, get component by class. This will be a ability manager component. And we will return this right here. And we can actually return them all. No, let's just return that one. So this is the bpass ability. No, let's just get them all just to save some space. So we're just getting all the components associated with the ability system for whatever actor we're inputting in this function. And we'll make this pure. And in our bpass check has tags, we'll say actor to check. And we will get their bpass system if they have one. We will make a gameplay tag container. So tags to check. And we'll make a couple of variables here. Let's say of type Boolean, we'll say has all question mark, has any question mark, and exact match question mark. And this is just me trying to combine a bunch of little functions into like one function, just to save space. So the tags we want to check. So we'll get our gameplay tag manager component. We'll get our gameplay tags, and we'll get a sequence. And the first thing we're going to check is if tags to check, we'll say has any. So has any and has all. So has any, we'll do second, and has all, drag exact match in there. And basically this is going to get a little messy, guys, so sorry. I'm going to drag this up here. And basically we want to check if our gameplay tag, manager gameplay tags, if our bpass gameplay tags contain all of these tags. And if they do, we will just exit the function and not even worry about continuing on in the sequence. So our return node is just going to be check passed. And so we are checking here. We're checking here if it has all the tags. So, oops, I did this wrong. Has all. Wait, sorry. So, oh yeah, sequence 1, if has all is true, then we want to do another branch actually right here. And if has all is true, then checks pass. If not, it's going to fail. It's going to false, and it's not going to leave the function. It's going to go to this one, which this one is has any. So we'll drag the exact match in, and we can actually make this a little neater by get exact match. We can type it, but it's just that input variable. We can duplicate it, put it up here. And instead of this all the way here, we can say get has all. There we go. So if has all is checked, it's going to continue right here and check if it has all. If not, it's going to false and it's going to go down here. And we're going to say if get has any. If this is checked, then it's going to check if this right here, if our bpass gameplay tags have any of, here we can make this even neater, get tags to check. I'm just organizing this a little bit, guys. Duplicate that, tags to check. And if it has any of those, it will return checks passed. If not, let's see, what do we want to do if it doesn't have all of them and doesn't have any? Let's just leave it like that. That'll be good for now. There we go. Okay, so in our ability manager component, we can say check source bpass tags. And we can get our ability base data. Say ability by tag. Oh, oops. Ability tag, and we can change this to check source. Or no, check ability. Sorry, check ability tags. Check tags by ability tag. And ability tag, and so we're going to get ability definition by tag. Oh, this is a base ability. So we will. Oops, so gameplay tag. And we will get ability tag, which is just going to be this input right here. I'm going to put it in there. And we will say, if we found this, ability definition found, we will break it. And wait, actually we can change this to can activate ability, question mark. And we'll have a return node for output. We'll have can activate ability, question mark. And if this ability tag, if it's not found in our database, then we want to, of course, fail this. And then right here, we're going to get all this. We're going to get all this ability data, and we'll check the restricted and required tags. So we'll say bpass check has tags. Wait, this can be pure actually. bpass check has tags, pure. Go into our, there we go. And we have this. The actor we want to check is our owner. And the tags we want to check for are the restricted tags. And we want to see if they have any. And if they have any, if they have any, this will come in true. So we really want not, because we don't want them to have any of the restricted tags because they're restricted. So if they have none of the restricted tags, we can keep going. And we can actually do a show debug right here. This will make it easier to debug. You can say print string. And so we're basically just going to help ourselves identify why something would be failing. So the restricted tags, we want to check if it has any at all, because if we have any, oh wait, and this is source, actually we want to pull off a source. So if the source restricted tags, we are the source. If we have any of the restricted tags, we want this to fail. And so we will say can't activate, well, I'm gonna put it in caps. Can't. I'm gonna put has restricted tags and return. Let's actually do a sequence right here. And the first thing we'll do is do the debug if we need, and then return, because we want to exit and fail the function if it has any of the restricted tags. I'm going to duplicate that and duplicate this. And the tags we want to check are the source required tags. And we want to see if we have all of them, and we want them to be an exact match. So this will only come in true if we indeed have all of them. Now, if we don't, we want to do the same thing here, but I'm going to print something different. Let's actually say source. So source has restricted tags. Source doesn't have required tag. I'm going to make it apostrophe. The S in parentheses, because it could be more than one. It's just any of them. Okay, cool. And before we even do any of this, let's just see. So we want to make sure that the ability definition is found, but we also want to make sure it's in our, not our default. We want to make sure it's in our granted ability tags. Because if this ability right here is not granted to us, then we want to fail immediately. And then I'm going to duplicate this again. Get rid of this. And that way this portion will be easily debuggable. Because at every branch, we're going to print something, and we'll make this show debug true, by the way. At every branch, we're going to print the reason why it's not being able to activate it. Definition invalid or not granted. Cool. So if we check all the source, the target restricted and target required, we're gonna get to those. But for now, we're just gonna roll with the source stuff, and we'll actually build in a check for the commit cost, which is going to be like the attribute cost for activating the ability, but we're going to skip on that for now. We're just so we can get something going. So if we check all the source restricted tags, if we check all the required restricted tags, we check that the ability is in our database, and we are granted the ability, then I think we're okay to actually perform the ability. So we want to, so if we get to this point, we want to get this class reference right here and construct object from class. And we can just organize this a little bit, and you'll see that, usually this node is like, it ends right here. It only has class and outer, but because we set all these variables to expose on spawn inside our ability base, we can actually pass in these. So, we need to do our owning character. So if we go to event begin play, we can get a sequence. First thing, let's actually do this second. The first thing we want to do is get the owner. We're going to cast to character, and keep in mind, this is not casting to a specific character. This is casting basically to the character class as a whole, and we can make this a pure cast. And on success, we are going to promote this to a variable as owning character. We will make this private and throw it into our private category and connect it to true. Just organize this a little bit and try activate ability by tag. No, where am I? Can activate ability. So let's actually, I'm going to control X that, what I was just about to do, because I forgot this was a helper function. So if we get to true, we're going to say yes, we can activate the ability, and we're going to take this ability data and put it right here. And we need our ability context as well, because that was passed in, I believe. No, okay. So try activate. Yeah, here we go. So can activate ability. We'll make it pure. We'll get ability tag. And so basically any logic that we want to check if we can activate an ability, we're going to put it right here in this function right here, which I believe can be a pure function. Let's just not make it a pure function because we are printing strings. So let's not make it a pure function and connect it up. That's just because we're printing strings. I'm not sure if you can print strings on a pure function. So if we can't activate the ability, we're going to break out of this. And we're going to say, we'll pull off this and construct object from class. And there is our exposed variables. And we'll get right here and get our get owning character. We'll get our show debug. We will get our ability base data, which is here. And we will get our context, which is here. And our owning BPass manager component, we will get a reference to self. We need to create another variable for active abilities. And this is going to be ability base. Yep, ability behavior base, and it's going to be an array. And if we pull off of here, we should be able to, yes, activate ability, and then we can add a unique item to this array of active abilities, which will be this right here. Ooh, and I just remembered we need one more thing to check. Sorry, my computer's making that noise. Let's see. We need to check if it's blocked. So we need to get blocked abilities. And we will basically just loop over all our abilities. We will get the associated ability data. We will get the, oops, sorry. We need to break this. We need to get the ability tag. No, not the ability tag, sorry. These are all our active abilities. So we need to get the, where is it? Did we not put cancel? Yeah, it looks like we didn't. So let's go back into our data structs, ability-based data. We need gameplay tag containers for block abilities with tag. I'm going to put this after target required tags. And cancel abilities with tag. This is a, yeah, they're both gameplay tag containers. And let's go back into our ability manager component. We can compile, and there it is, block abilities with tag. So we basically are, let's see, is blocked ability question mark. And we can actually just get a for each loop with break. We can have an input of a ability tag. And we will basically see if this block abilities with tag has the ability tag that we're inputting into this function. Making an exact match. And if it does, we are going, I'm just going to promote this to a local variable, and is blocked ability question mark local in parentheses. And I'm going to unconnect this and just connect true. And then I'm going to break out of this loop. and then we can go into completed and hook up our thing. So basically this will tell us if the ability is blocked or not. So we'll make this a pure function as well. And we can go into our can activate ability, and off this branch right here, well, we can maybe do this sooner. So let's say right here, maybe we'll do true, and we'll say is blocked ability, get ability tag, and we will continue. Oops, I didn't delete this local stuff. Is blocked ability, can't activate ability, is blocked ability. So this will be not if it's not a blocked ability. We want to continue on the true path. There we go. And I'm going to just bring this over here. I'm going to actually duplicate it and connect the false. And if show debug is on, we can say in all caps, I'm putting is blocked ability. Cool. And so try activate ability. There we go. Cool. And so let's go to our what is it? BPass. Let's go to our data. Let's go to our table because I don't remember if I put it. Yeah. So let's say, yeah. So our ability tag, let's put jump, and I will sprint, do sprint and jump. I'm going to go into our ability behaviors, go to player behavior object, and we will say, I'm going to create a child of our ability behavior player and say ability behavior player debug. And basically I want to just put this debug for both of these. And I want to basically for the jump, when we activation grants jump, I want to give it the jumping state. And then when we try to sprint, I want to say, so actually in our jump where it says block abilities with tags, we want to block, what is it? Jump. No, sprint, sorry. And also restricted tags. Source restricted tags will be jumping. No, sprinting, sorry. Well, actually, I'm getting these mixed up. One sec. So this is jump, activation grants tags, and deactivation removes tags is going to be jumping. Sprinting is activation grants tags is going to be sprinting, the state of sprinting, and deactivation removes tags is going to be sprinting. Cool. And so let's go into our, because we didn't even do that. So let's go into our BPass ability manager component. And after we activate this right here, we will just get our gameplay tag manager components, and we will actually make a custom function for, like, we'll build the attribute and the gameplay tag manager out a good bit more, but for now we're just going to add the gameplay tag like this. This is just a debug because this episode has gone pretty long. So let's say activation grants tags. We'll break out of this. We'll do a for each loop. And basically we'll say to add this gameplay tag when it is activated. And so an easy way to debug this is going to be going into our database, and let's say while we're jumping, we can't sprint, right? So jumping, activation grants tag is jumping, and sprinting, we will say restricted tags. Where is it? Source restricted tags. Source restricted tags, we'll say jumping, but we'll also say for jump, we'll say block abilities with tag. We want to block the sprint ability. So that's just kind of showing how there's a couple different ways to block things. And the reason why we have block abilities with tag and restricted and required tags is because you can block abilities with tags, but the restricted and required tags, those could have to do with an ability or not, So if we go into our third person character, I'm simply going to delete the jump functionality. And right here, I'm going to say try activate ability by tag. And the ability I want to activate is jump. I'm going to get a debug left shift. I'm going to duplicate this and drag this down, say target. And if I do the left shift, I want to sprint. And if we go into ability definitions, we have jump and sprint. Let's see, let's give this a shot. So definition invalid, not granted. See? So if we go into our gameplay ability manager, I never granted the ability to the character. So if I go into our third person character, our BP ability manager component for debugging purposes, I'm just going to give us the jump and sprint ability. So if I jump now, jump is activated. Now, if I try to sprint, it's not going to work. Let's see real quick. So jump, wait, this is sprint. So block abilities with tag. I might not have done that. So try activate ability. Oh no, can activate ability. We'll say is blocked ability. So show debug, yes. So if it is a blocked ability, yeah. Block abilities with tag contains this. Cool. So let's see if this can. Oops. No, it's this right here. So debug key 1. I'm gonna do that right there. Go. So there we go. So that's, I don't know why that left shift debug wasn't working, but for instance, so we're jumping, we're in the air, we press 1, we cannot sprint. It's a blocked ability. I think that's going to be a good stopping point. In the next episode, we'll figure out how to add, how to place some montages and stuff. But in principle, this is going to work if it's blocked, if you have other tags, etc. And this is the basis of a good ability system. Now we still have a couple things to add, and we still have to fill out the attributes in the gameplay tag manager. But it's already been an hour and a half, so I'm gonna end this episode and pick back up in the interaction and inventory system, adding the equipping items and stuff, and then I'll double back for episode 2 of our blueprint ability system. Be sure to check out the Discord and Patreon if you want to get involved in the community, and I'll catch you guys next time. Thanks for watching. See ya.